1. So the square root's going to be in a blue line, and 1 is going to be the red line. We want to know when is it going to be greater than that. So if I go to my graph and draw myself a line, 1 would be about there. Should have done that in red. Sorry for the confusion. No, oh, I can't do it in red. Man, 2024. And then 7 minus x is going to start over here, and it's going to make its way in this direction. So when is the square root function bigger than or greater than the line of 1? Well, all the way from the beginning of time, this blue line has been above that red line, and it only goes below it at this point right here. Somewhere, my line is not great. It looks like it happens at about 6. So let's see mathematically how we can solve, or algebraically how we can solve that thing. So if we square both sides, we get 7 minus x greater than 1. Keeping in mind that 7 minus x has to be greater than or equal to 0. So that means x has to be less than or equal to 7. Why does it have to be less than 7? Let's go to the calculator real quick. For some reason, I am at, can I scroll? Okay. Why does it have to be less than or equal to 7? We see at 7, the value of that square root side is 0, but any higher than 7, and it starts to be an error because it's taking the square root of a negative number. And so that's not even a part of that thing, that function's domain. So let's subtract 7 from both sides. We get negative x has to be greater than negative 6. Divide by negative 1. Flip the inequality sign. X has to be less than 6. And that is our solution for this. You see, here is when x is equal to 6. And anywhere on this side of that function, anywhere on this side of that vertical line, the inequality is going to be true. So x has to be less than 6. If we wanted to write that in interval notation, we would put negative infinity, comma 6. So you can go as far in the negative direction as you want, and all of those numbers will create a true inequality here. But it only stays true up until 6. Right, let's get rid of this. And look at number 3. Two x minus 1 and 3. So we want to know, when is this square root function going to be less than or equal to 3? And if you graph it, you could find the intersection of this point right here. That is not the intersection, but it's kind of close. You find the intersection, and you can see that the function is less than that for a little while. It starts at 1/2, which is about right here, and works its way up. When does it pass 4? Around 8. It goes like that. And then our other line happens at 3, which is about right here. And so there's this little window from like here to here where that function is less than 3, less than or equal to 3, and nowhere else outside of it. So only in this region right here. We want to know, when is that region happening? If you look at the table, I'm going to go up by halves, and you can see that you get errors all the way up until when x is, or b is 1/2. And then you start to have a value for the function, and you can see it is less than 3, less than 3, less than 3, less than 3. And then boom, equal to 3 at 5. So it looks to me like from 1/2 to 5 is going to be our answer. And let's see how that plays out in our algebraic solving here. So if you square both sides, which is what you should do, you get 2b minus 1 has to be less than or equal to 9. You add 1, you get 2b less than or equal to 10. Divide by 5. B has to be less than or equal to 5. And so that's part of our solution. So it's saying all the x values that are to the left of when x is 5 are going to solve my inequality. The only problem is that I start to get errors. So where does that 1/2 come from? Well, it comes from underneath that square root, 2b minus 1. If you want real solutions, that number has to be greater than or equal to 0. So b doesn't have to be greater than or equal to 0. 2b minus 1 as a whole, when you plug in a value for b, that number has to be greater than 0 or equal to 0. So you add 1, divide by 2, you get b has to be greater than or equal to 1/2. So we have two constraints on b, on what b can be. It has to be greater than 1/2 and less than or equal to 5. So you do it like this. If you want to do that in interval notation, we would do brackets because 1/2 and 5 are included. Lowest value for x or b is 1/2. The highest value is 5. All right, let's skip to one that gives us a quadratic. Skip up to down to number 5. Get rid of all that. Let's go with purple and look at number 5. So here things get a little bit sketchier. 8 minus, nope. We got x, we got 8 minus 2x. So when is the x, the red line, above the blue line? When is the red line above the blue line? Let's see. I want to change my window a little bit. You can see that the red line passes the blue line and gets above it somewhere around 2, and it will stay above it forever. However, part of that solution isn't really a solution because it's not even a part of R's domain. So what do we mean there? We mean that if we want to actually solve this inequality, this number, 8 minus 2R, needs to be greater than or equal to 0. And that only happens when R is less than or equal to 4. A boundary, a constraint on our, it's a constraint on our domain or on our solution. If we get solutions that are bigger than 4, they just really aren't solutions at all. They're because they give us errors. All right, so let's find the other side of that. I'm gonna do it on the calculator first. If you do second and trace, you can do an intersection. Mine does it a little bit differently than the calculator, but you usually just hit enter 3 times. I actually have to left and right bound this thing. Those two things will be in the same place. So let us work through this. I'm going to square both sides. R squared greater than 8 minus 2R. It's a quadratic, so I'm going to move everything to one side. It's greater than or equal to 0. And then I'm going to factor this thing. Positive 4 and negative 2. So I actually get two solutions here, negative 4 and 2. And you can look at the graph and you can see that at negative 4, there's really, it's not really greater than, the R is not greater than that. So what's going on there? Well, what we're really only finding is that that we have an extraneous solution, and you could plug these in. But so what you usually do with a quadratic and an inequality, quadratic inequality, is you do what's called a sign test. You put your zeros on this little number line. So these would be values for R. And basically we're gonna plug them in right here and see which ones give us true statements. So if you pick a number that's on the left side of -4, let's say -5. If I plug in -5 right here and right here, I would get -1 times -7, which is a positive number. It is greater than 0. You can't tell my brain just exploded. Oh, okay. No, it's fine. Everything's fine. And then a number between -4 and 0. So it looks like that's doing exactly what we want it to. A number between -4 and 0, or -4 and 2, which I'm going to pick 0. If I plug in a 0 here and here, then that's going to be a positive number times a negative number. That's negative, which is not greater than 0. So this region can't possibly give me a solution from -4 to -2. And then at the end here, if I pick a number greater than 2, like 3, I would have 7 times 1, which is 7, which is a positive number, and that means that this area and this area could give me solutions. So what are we going to do? Well, what I would do is we're going to check for extraneous solutions up here. So we know that they have to be less than, we know they have to be less than 4, less than or equal to 4. So they have to be somewhere down here. So these could be solutions, and then also these down here. I'm going to check maybe like 3. No, 3, yeah. If I put 3 right here, I put 3 right here, then I get 3 is greater than the square root of 2. And the square root of 2 is 1.414. So 3 is greater than that. So I know that this actually does work, that region right there. So my solutions are definitely from 2 to 4. What are my solutions? Nope, that should not be a parenthesis. 2 is not included. 2 is close. It's just the boundary for it. What about -5? If I plug in -5 here and -5 here, then I'm going to have the square root of 18 is less than -5, or -5 is greater than the square root of 18. That is a lie. That's not true. So those actually aren't parts of the solution. The real solution is between 2 and 4, or you could say x has to be greater than 2, less than or equal to 4. These are two different ways to write the same answers. Now, I know that that was a lot, so let's go back to the graph. How does a graph help us answer this question? All this region stuff that I did over here, all this stuff, is a really valuable skill, valuable to be able to do algebraically, because sometimes the calculator can be a little misleading. But what's not misleading is that this red line is definitely only above the blue line from 2 to 4 before we start to not get any numbers for the blue line. And it's definitely not above it over here. So we know just from looking at the graph, the answer must start at 2 and end at 4. Even if these weren't nice and neat numbers, we could still get them by doing factoring the quadratic formula, solving over here algebraically. So that's number 5. Number 6, we'll do one more for the love of algebra. I'm putting 8x minus 12 because it was easier for me, and that's the same as -12 plus 8x. And I'm going to graph them. When, again, is that red line below the blue line? Window. I'm going to change my window again. You can see it a little bit better. When is the red line below the blue line? You see that it starts being below here and stops being below here. So there's just this little window where the blue line goes up above it for a second and then comes back down. It looks like we're not going to have any problems with these imaginary solutions. So you still should say Negative 12 plus 8x has to be greater than or equal to 0. So you get x has to be bigger than 1.5, but all of our solutions are going to be bigger than 1.5 anyway. So we're going to square this. We get x squared less than or equal to negative 12 plus 8x. It's quadratic, so we want to get everything to the other side. So we can factor or use the quadratic formula. These all factor, by the way. And when we get here, here's the problem. Here's why we have to do that little line thing and check all the solutions, is because, and I'm going to tell you a shortcut here, is because we have to do that because this is going to tell us when this is equal to 0, but it's not going to tell us which side of 0 it's on. Our solutions will tell us it's 0 at this point, but is it after it passes that point? Is it less than 0 or is it greater than 0? We don't know. So here's what we're going to do. We're going to factor. And actually, I'm just going to set it equal to 0 because we don't know nothing about this negative sign. Factors of 12 that add up to negative 8, negative 6, and negative 2. So that means I get x equals 6 and x equals 2. And these are the numbers I'm going to test between them and see which of these is correct. So the nice thing about this is the shortcut I promised you, is that these will alternate, these regions. So basically we've got region 1 here, region 2 here, and region 3 over here. And we want to know which region are my solutions in, or maybe it's both or two of them. But these will only be less than 0 or negative if I plug in a number and it gives me a number less than 0. So I'm going to try like a number that's over here in this range in region 1 is 0. So I'll plug in 0 here and here. I would get 0 plus 12, which is 12, is less than or equal to 0. That's not true. So this would be a positive number and also would not be a solution for us. Now, here's the cool thing. These guys alternate. So if this region is positive, then this region is negative because of the way the function works. If we have two zeros here, if it starts up here, there's only one place it can be after those zeros, below the graph. And then after that 0, the last 0 at 6, it's going to be above the x-axis. So the only region that's negative, and you can plug in a number and try this, like a 4 here and here, and you'll see that that's going to be a negative number, is between 2 and 6. So we're going to keep our, we're going to create our inequality sign and to show that we're between these two things. So x needs to be greater than or equal to 2, less than or equal to 6. And you see that none of that violates x needing to be bigger than 1.5. And you could also write it in interval notation like this. And those are your solutions.